Today's notes are on graphing linear inequalities. In standard form, an equation is in the form of ax plus by, and then is either less than, greater than, less than or equal to, or greater than or equal to c. We also have slope-intercept form, which we're used to seeing y is equal to mx plus b, and because it's a linear inequality, we are then again using the symbols less than, greater than, less than or equal to, and greater than or equal to. Your solution for a linear inequality is a set of points that make an inequality true. So first, we're going to check and see if a set of points is a solution to a given inequality. So scroll down and look at example 1. We are going to decide if the given points are solutions to the inequality. So knowing that a point is x comma y, I'm going to plug in -2 for my x's, and anywhere I see a y, I'm going to plug in -9, and then I'm just going to simplify both sides. So this is -8 plus 18 is greater than or equal to 8, which simplifies to 10 is greater than or equal to 8. This is a true statement, so I can say that yes, this is a solution. If I do the same thing, but this time I'm going to plug in 3 for x and 5 for y, I end up with 4 times 3 minus 2 times 5 is greater than or equal to 8. So we get 12 minus 10 is greater than or equal to 8, or 2 is greater than or equal to 8, which is a false statement. So I can say that this point is not a solution. Please try example 2, part A and B on your own. Decide whether those 2 points are a given solution to the linear inequality -2x plus 1 is less than or equal to 3. Next, we're going to talk about the steps for graphing a linear inequality in 1 and 2 variables. So the first step, if it's in one variable, so just an x or just a y, is going to be to get the variable alone. If it is a 2-variable equation, so it has x and y, such as example 1, your first step is going to be to put it in slope-intercept form. So example 2 from above would be an example of a 1-variable equation. Example 1 from above would be a 2-variable equation. Your second step for either of them are going to be to plot your points. Step 3 is going to be to connect with a solid line for greater than or equal to and less than or equal to, and you're going to use a dashed or a dotted line for greater than and less than. Your last step is going to be shading. So you're going to test a point, and you're going to shade on the point if it gives you a true statement, and the other side if it gives you a false statement. Please flip it over and look at the next page. Let's practice graphing some lines. Right, for example 3, because this is in one variable, our first step is going to be to get the variable by itself. So I'm going to add a 1 to both sides to get y is greater than or equal to 4. Then I need to graph this, remembering to our little anagram for hoy. So the y tells me that this is a horizontal line at 4. Because it's greater than or equal to, I know that it's going to be a solid horizontal line. And then I need to pick a test point to figure out if I'm going to shade above or below the line. So 0, 0 is an easy test point to pick. So if I plug 0 in for y, I get -1, which is greater than or equal to 3, which is a false statement. So I would not shade where 0, 0 is. I would shade the opposite region. Let's look at this again for example number 4. This one is a vertical line, and it's going to be at -1. I also need to note that this is going to be a dashed line. So I have a dashed line at -1. And I'm once again going to use 0, 0 as my test point. So I have 0 is less than -1. This is false. So because 0, 0 is on the right side of my line and it gave me a false answer, I'm going to shade on the left side of my line. Let's scroll down and look at example 5 and example 6. Example 5 is already in slope-intercept form for us, so I can graph it by starting at the y-intercept, which is the point 0, 4. Then, because I have a slope of -2, I can count down 2 over 1, down 2 over 1, and I can continue this pattern until I have a few points that I can connect. Because it's greater than or equal to, we will be using a solid line to connect. And then I'm going to pick a test point in order to say which side of the line to shade on, and you can pick any point as long as it's not on the line. So if I use 0, 0 again, I get 0 is greater than or equal to -2 times 0 plus 4, which simplifies to 0 is greater than or equal to 4, which is a false statement. So because 0, 0 is kind of to the left of the line and it was false, I'm going to shade to the right of the line. For number 6, this is an equation in 2 variables, so I need to start by putting it into slope-intercept form, which means I'm going to subtract 3x from both sides. Then I'm going to divide everything by -2. So I get y is less than, my sign's flipping because I'm dividing by negative, 3 over 2x minus 2. So my y-intercept is 0, -2. And my slope is a +3 over 2. So I'm going to do that a couple times, count up 3 over 2. I'm going to have a dashed line because this is less than. So I'm going to connect these points with a dashed line. And I'm going to pick a test point. And I'm going to use 0, 0 once again. I can either plug it into the original equation or the one that I put into slope-intercept form. So this gives me 0 is less than -2, which is false. So because 0, 0 was false, I'm going to shade in the opposite region. For both 7 and 8, you need to put them into y-intercept form first, so please try doing these two on your own. We will go over them together in class tomorrow.